I'm Ryosuke Kojima from Kyoto University. In the next practice, I'd like to introduce the Hack software. We were able to launch the Hack Designer in the Practice 0, so the purpose of Practice 1 is the first GUI programming using the Hack Designer by constructing a simple sound source localization system. If you have a problem in the Practice 0, please ask the staff and concentrate to solve your problem. Basically, this practice is easy, that's why I think you can easily follow us later, after you can launch the virtual machine. Okay, let's start. The content of Practice 1 is to build a sound source localization system. We will build a Hack network and display the localization results. The Hack Designer has just started in Practice 0. Please check it again. You can manually select and click nodes from the nodes list panel. When you cannot find the node from here, you can search from this form to find the nodes. Here is a button to run the network. This file button opens the window to download and upload files. This button is to save the network. We will build a network in this canvas from now on. Here is tab to select the network sheet. This is a console to display standard output of the network. When you got an error message here and ask it to the staff, please copy it and paste to the Slack channel. This is an overview of network construction in the Hack Designer. First of all, we will drop nodes on the canvas and place nodes from node panel list. After that, we will connect them to realize the functions. Basically, the network is constructed by dragging from the output terminal of the source node and drop it to the input terminal of the destination node. If the type is matched, you will see candidate. To see the properties of the nodes, you can open the parameter setting window by double-clicking the node. This slide tips in Hack Designer. Hack supports these useful functions, so please use them when you need it. First, you can place the nodes by these two ways. It's time to delete it. You can delete node by right-clicking and selecting delete. If you are familiar with the keyboard, you can delete it by pressing the delete key while it is selected. To connect nodes, it can be done by drag and drop. To copy and paste nodes, the so-called standard copy and paste shortcut can be used. That's Ctrl-C and Ctrl-V. When you want to delete the connection, please be careful because the operation is slightly different from deleting the nodes. To delete a link, please right-click the input or output terminal and click delete the link. When you place a lot of nodes on the sheet, the nodes might get messy. When you want to align them, you can press this mark on the upper left to automatically align the old nodes. And when you want to add to a new sheet, please click this plus mark. This slide shows convenient functions. I hope you can use it when you need it. In Practice 1, let's actually make sound source localization system by using Hack. Overview. The purpose of this practice is to try building the system once, and the goal is to build a sound source localization system from scratch. Before starting this tutorial, please confirm the following files in the Practice 1 folder here. Everyone is running on a virtual machine, so I think it's probably okay. If you have a problem, please ask the staff. This example directory contains a completed network that will be created in Practice 1. If you have been stuck, the finished product is here. So in short, this is backup in this practice. Practice 1 is composed of two parts. In 1-1, let's build a sound source localization system with the fixed parameters. In 1-2, let's enjoy the sound source localization by changing the parameters. I will talk about this practice step by step so that beginners do not make mistakes. So if you are expert of Linux and such a system like Hack, it is okay if you go ahead and do it. Thank you. First, I'd like to talk about microphones. Since today is online, we cannot use actual microphone. So we use a pre-recorded 7-channel wave file. I recorded this wave file using a 7-channel microphone array called microphone. And two types of wave files are available. I will explain again in detail about this. I prepared three transfer functions. The first two transfer function files are used for 2-dimensional and 3-dimensional spaces. The last one is for another microphone array. In the last one of this practice, we can use another wave file recorded with egg-shaped microphone array called Tamago01 as an optional practice. These transfer function files are created by TSP recording or calculation. But in this time, we will use files created in advance. You can see how to create these files on YouTube channel. Please find Hack TV. From this slide on, we will create an SSL system. We will construct the system in these steps. This system is simple, but divided into several parts. This figure shows the concept of these steps. First, the audio wave files are loaded in the main network. Next, we will create a subnetwork for iterative process. In the iteration, the wave file is read sequentially, and these three steps are repeated for sound source localization. FFT, fast Fourier transform to convert the wave file into the frequency domain. Sound source localization by the music method, and tracking to chase the moving sound sources. The final part in this system is to display the SSL results. The tutorial. I think Hack is already running. If you have closed the window, please run it again by clicking Hack Designer's icon in the sidebar or running Hack Designer in Terminal. If you have left some nodes on canvas, please clear them by clicking this Clear button. First, please drop two nodes on canvas in the main sheet, constant and input stream. Constant node can be found in general in the node list panel. The input stream node can be found in I/O in the node list panel. Please add these nodes. At this time, please be careful that the nodes cannot be found on canvas if they overlap. You can move a node by dragging the node. After that, to connect these nodes, please click on the right side of this constant node and drag it to connect to the input of the input stream on this side. If you are concerned about the position, you can align the nodes by clicking the round mark on the upper left of this sheet. Next, we set properties for the constant node. When you right-click or double-click here to see a property, this window will open. First, please make sure that the type of this value is set as string, and input the name of the wave file in this box. In this case, please input practice1.wave. OK. Then, to create a subnetwork for the iteration, please push this plus button, then this window will appear. So please set name as loop0 and type as iterator. If you click add, you can see the loop0 tab. Please click the Loop 0 sheet. We will put the 5 types of nodes in the Loop 0. These 5. Audio stream from Wave in Audio I/O. This node is used to read the signal frame by frame. Multi-FFT in MISC for the FFT of multi-channel signal. Localize music and source tracker in localization for SSL by music and sound source tracking. And display localization node in localization to display SSL results. Please place the 2 display localization nodes into the canvas. After all, please connect these 6 nodes like this. Please do drag and drop to connect from audio stream from Wave to multi-FFT so that it looks like this. And from multi-FFT to localized music, from localized music to sound source tracker, from source tracker to the both of 2 display localization, like this. The hack system doesn't care about the position of nodes and shape of the links. Is it okay so far? If you complete the network, we have to set properties for each node. Many properties exist in hack. I will explain each one briefly. Most of the parameters can be set as default. From the next slide on, the only parameters with underlined letters should be modified. When you double-click on audio stream from Wave, you can see these parameters. The first parameters are length and advance. These properties specify how often the data is processed. This figure shows the relationship between these parameters and audio streams. Length means the frame size to process at one time, and advance means the shift size of each iteration. Please keep these properties as their defaults, and please change the use wait flag to true. If this is set as true, the program is executed in real time. If this flag is set as false, it will run as fast as the computer allows. But in this case, we want to see how this localization is carried out, so please set as true. Next, we'd like to set the parameters of the FFT. Basically, you can keep the default settings. The length represents the FFT point size. In the FFT, it is common to use a window function together. You can choose the window function you like. The length of the window is usually same with the FFT point. Next is localized music. This is a main node of localization system. The first parameter is the music algorithm. Actually, music method has many variations. Hack supports many localization methods. SEVD is the most standard music algorithm. And second parameter is TF channel selection. In this case, our input wave file contains 7 channels. This setting is to select the channel for processing. When setting like this, all channels are used for localization. The frame length is set as 512. It is the same as specified in the multi-FFT node. And this sampling rate parameter should be set as sampling rate of the input wave file. In this case, we will use the one recorded at 16 kHz. So we set this parameter like this. Next, we have to specify the transfer function here. In this practice 1-1, we use tf3d.zip. The window parameter means the number of frames used to calculate the correlation matrix. Because in music method, correlation matrix should be estimated. How many frames are used to estimate the correlation matrix should be specified here. Next, window type is a parameter of how to select the frames to calculate the correlation matrix. Period parameter specifies how often the SSL is computed. If the sound source localization for every iteration, the computational cost will be very high. This means that the estimation is done only once every 50 frames. Furthermore, the parameters for localized music still exist. These parameters are changed in Practice 1-2. There we will see what happens when these parameters are changed. This first parameter allows us to specify the number of target sound sources for sound source localization. Because this number is a support parameter of the music method, the actual number of sound sources may be higher or lower than this number. Next, you can select the minimum degree and maximum degree of the direction to search the sound sources. For example, when you can assume that sound comes only from the front, you can specify these parameters as minus 90 degree to plus 90 degree. Next, there are lower bound and upper bound frequency. These parameters represent a frequency band for sound source localization. The remaining parameters of localized music are more detailed parameters. Spectrum weight type can be used to select frequency weights. Enable eigenvalue weight is also related to weights. These weights are related to the detail of music method. If you're interested in these parameters, please see the HARC document on the website. Then, the maximum out peaks specifies a limit of sound sources. -1 means no limit for the number of sound sources. Finally, this flag is for debugging. So if you set is to true, you can see a lot of information in the log. After the localized music node, I'd like to focus on source tracker node. To track sound sources, this node integrates of SSL results frame by frame. This description is criteria and concrete algorithm to track sound sources. In short, if the power of sound source is small, there is the tracking it. If sound breaks for a moment, we assume that it continues to track it. If the two sound sources are close, these are regarded as the same sound source. In the next slide, I'll explain these parameters in this criteria. Because the parameters on this slide are very sensitive to the results, we have already searched for the best parameters. Threshold parameters is set to 34 and pause length is set to 1500. The minimum source interval is set to 30. Of course, the best parameters depend on data. In practice 1-2, we will change these parameters. In HARC system, an identifier is assigned to a sound source. This number is minimum ID for sound sources. Finally, debug flag is the same as the other nodes. The last part in this system is to display SSL results. The two display localization nodes exist in this network. This is the first display localization node to display the azimuth angle. To clarify the role of this node, the name of window is azimuth. Please make sure the plot type is set to azimuth. The other node is for displaying the elevation angle. It will be displayed in the height direction. So let's set the window name as elevation. The height direction is only from -90 to +90 degree, so please set the value range to -90 to 90. Please modify plot type to elevation. That's all of parameter settings, but another important thing in Hack is setting terminal. Especially in the case of iterator sheet, these three terminals should be determined. Input for subnetwork. It means the data comes from the main sheet. Output for the subnetwork. It means the data is sent to the main sheet. Condition. A condition for terminating the file sentence. If this condition terminal becomes false, the iterative process is terminated. Okay, in this case, please set terminals like this figure. The input should be the input of this whole loop. So please right-click the input of audio stream from Wave. Then a menu will appear. Please select Set as Input from the menu. By the same way, please right-click Not EOF terminal of output stream, audio stream from Wave and select Set as a Condition from that menu. EOF is an abbreviation for end of file. By this setting, the process repeats until the end of the wave file and terminates the iteration after reaching the end of file. For the output, please select a display localization output, right-click and select Set as Output. Similarly, please right-click and select Set as Output for another display localization node. In this way, these nodes are automatically named as Output and Output 1. It doesn't matter which one you name. If you added these settings by mistake, you can delete the terminal by right-clicking on the terminal and deleting the terminal name. That's all for sheet 0. Please move to the main sheet. Then you can find loop 0 in dynamic in the node list panel. Please drop the loop 0 node on the main sheet. Then you can see one input terminal and two output terminal as you can set in the previous slide. If you cannot find them, you make some mistakes. Please confirm the loop 0 sheet, or if you have some trouble, please ask the staff. Then please connect loop 0 to input stream like this, and right-click the output terminal of loop 0 and select Set as Output. After all, the final network is Practice1-1. It looks like this. Is it okay so far? Once your network is complete, please save the file using Save button with the file name practice1-1.n and click OK. After saving network, please open the file manager by clicking this file button and click if practice1-1.n is saved. Then the following files have to be uploaded before execution. To upload transfer functions, please click the Choose Files and select tf3d.zip from this directory. You can also drag and drop tf3d.zip on this window to upload the transfer function. Please upload the audio files by the same way from the file manager. You can choose two WAV files from Choose File button, or drag and drop the audio files into this window. If you accidentally upload other files, you can delete it by the X button, but extra files are not a problem to run the network, so you can ignore them. Then, let's try to run the network by clicking the execution button. If successful, these windows will be displayed. If you have some trouble in this step, please see the status in the upper right box in Hark Designer. In this practice1.wave, 3 speakers in the horizontal plane. As a result, the elevation angle is always 0, and the correct azimuth angle are minus 60 degree and 0 degree and plus 60 degrees. Like to change the input file name, please open the property of constant node and set value as practice1_2.wave. If successful, these windows will be displayed, and in display1_2.wave, there are 3 speakers with variety of elevation. Please note that these scales are different, but the azimuths are minus 60 degree, 0 degree, and plus 60 degrees. And the elevation angles are minus 30, 0, 30 degrees. Like this. If you have an error in practice 1, please ask the staff, or since there is a completed network in example directory, I think it's okay to load that. I'd like to introduce practice 1-2, but if you have some trouble, please focus on your trouble. Practice 1-2 is about changing the parameters in practice 1-1, so you can easily catch up. 2 means modifying the parameters so that they can be changed dynamically. It is the same setting as before, but only one, this part will be added. By adding this node and connect it to the 2 nodes, it will extend your network. I'll explain how to construct this network. The first step is to add additional input terminals for localized music and source tracker. The second step is to add 1 node and 2 links to your current network. First of all, you need to add input, so right-click Localize Music and select Add Input. Then, this window is displayed. Please enter params here in uppercase. After that, params will appear in the input of localized music like this. Do the same thing for your source tracker node. Right-click source tracker and select Add Input. This window is displayed. Please enter params here in uppercase like this. After preparing 2 params terminal, please add Hark params dynamically conf from MISC in node list panel. Please connect these 2 outputs to params related to localized music and source tracker like this figure. After all steps, the final network in practice 1-2, it looks like this. Is it okay so far? Okay. Before execution, please save this network as practice1-2.n from the Save button in Hark Designer. Please be careful, the execution consists of following steps. First, please press the execution button in Hark Designer for SSL. Next, please right-click this directory and select Open in Terminal, and input this command, Python send hark param.py, file executing the network. And then this window will open. These parameters can be modified from this dialog, file executing Hark network. For example, when the threshold is lowered, a lot of noises will be localized. When the localization range is limited, only that limited range will be localized. Enjoy. But the current version of Hark, some parameters cannot be modified. This window might be crashed when some parameters are modified. This reported bug will be fixed soon. And if you have time, please challenge this optional practice. This practice is for another microphone array. In this case, a different TF data file and wave file should be uploaded. And then these two parameters should be modified. To sum up this tutorial, the purpose of this tutorial is the first experience in Hark Designer and Hark by constructing a sound source localization system. That's all in practice 1. The following tutorial deal with sound source separation and recognition using Hark. If you have any question, please ask from Slack. Thank you.